Okay, so here's your 3.2 video. So continuing on with linear equations, looking at graphs and tables as well as the actual equation, which we will be coming up with today. So today we're going to learn and talk about what does it mean to be a solution to an equation, and then how can I find a solution using a table or an actual graph. So we're going to be looking at tables and graphs and determining if we have a solution to an equation, and actually what does it mean to be a solution. So how is that going to look? What kind of problems are we going to see and be able to answer by the end of this section? Go ahead, read through this, pick out the key information, stop the video, and once you have done that, come on back. So concepts that we learned in this section as well as throughout chapter 3, we will be able to come back and solve problems like this, and we will be solving problems like this in tomorrow's class. So let's look at kind of a little bit of a review here. Solve the equation for x. So what does that mean? That means we want to get x all by itself, so alone. So actually probably go ahead and stop the video and see if you can go ahead and do it. So we want to get x by itself, so what can we do? We're saying 3 plus x, or we're adding 3 to x, equals 8. So 3 plus some number is going to equal 8. So how do I isolate or get x by itself? Because I'm adding 3, I want to make this 0. We know 0 plus x is just x. So if I can make this 0, I get x by itself. But if I subtract 3 here, I have to also do it on the right side. Remember, keeping everything balanced. You subtract 3, you got to do the same thing to the other side to get it equal again. So 3 minus 3 is 0. We still have this x. 8 minus 3 is 5. So x equals 5. So, for x to be a solution, so think about what it means to be a solution, 3 plus some real number must equal 8. So that real number is going to be what we represent x with, or what x represents. Never forget in an equation, the left side must equal the right side. Keep the equation balanced. So whatever we do to the left side, we have to do to the right side. Okay, we can and will be solving more complicated problems using a table. So that was just a one-stepper. We just had to subtract 3 from both sides. But now we're going to look at how to find solutions to a little bit more complicated problems. So just to kind of get us started, because we'll progress into solving them algebraically, we're going to look at tables. Okay, so we're going to solve this equation using a table. 10 equals 3x plus 4. So again, what does that mean? 10 equals 3 times something plus 4. So some things that we want to consider before we jump into making this table. What value of y do we want? Well, if you think about it, what do we want the right side to equal? We want to equal 10. We want left side equal right side. So the value of y we want is 10. So when I plug in 3 times something for x, and then I add 4, I want that outcome, that y value, to be 10. So what does it mean to be a solution? It means left side equals right side. It means it makes the equation true. So what does it mean to be a solution? Makes the equation true. Left side equals right side. And we'll look more at that tomorrow and more as we go through this. So we can create a table of values. So it's kind of a trial and error. We're going to start plugging in numbers for x and see what works. So with this situation, I said, okay, let's just look at those positive numbers to get us started. Now these may or may not give us what we want, but it's kind of a starting point, and we'll predict where to go once we plug in some numbers and see what happens. So let me come back up here. What was it? 10 equals 3x plus 4. So I'm going to just jot that off to the side. 10 equals 3x plus 4. Okay, so I'm going to take those x values and plug them in here and see what is my y value. So when x equals 1, what do I get? So we have 3 times 1 plus 4. So I'm just substituting the x value in. 1, I sub it in for x. So 3 times 1 is 3 plus 4, I get 7. Then I want to substitute 2 in for x. 6 plus 4, 10. 3 times 3 plus 4, 9 plus 4 is 13. x is 4. What do I get? 12 plus 4 is 16. And then 3 when x is 5. 3 times 3 plus 4. 15 plus 4 is 19. Okay. So we have our table of values, and again, we don't know if we have the right answer yet or not. We might, though. Circle the row that provides the solution to the equation. So again, what did we want y to equal? We said 10 equals 3 times something plus 4. So this is kind of representing our y value. So what value of x made the equation true, or became a solution, or made the right side equal 10? Well, when x was 2, y equals 10. So the solution is 2. So x equals 2 is the solution, because 3 times 2 plus 4 equals 10. So when x is 2, y, my outcome, is 10. Let's think back to what we did in section 3.1. I want you to go ahead and look, and this will be what you put down for me for tomorrow. Look at your x's and your y's and tell me, do I have a constant increase or a constant decrease situation? So kind of building off of what we did yesterday. Looking at these values, write down now, is this a constant increase or a constant decrease situation, and be able to tell me why. I also want you to go ahead and answer, why might this table, making a table of values, why might it not be the most easy, the most efficient way to find a solution to a given equation, or a way to solve an equation? So what might be hard about it, maybe? So now we're going to look at, would this x value represent a solution to the equation? So when we plug in x, does left side equal right side? So when I have 11 minus 9 times something, in this case 4, will that equal 47? So let's take a look at some of these. So we are checking to see if the value of x is a solution to the equation. So it doesn't make the equation true, does left side equal right side? So 11 minus 9, what am I plugging in for x? 4. So 11 minus 36, does that equal 47? So essentially we're asking the question, what is 11 minus 36? So does negative 25 equal 47? No. So x equals 4 is not a solution. It doesn't make the equation true. Okay. So again, you plug in, does left side equal right side? So let's try it with b. Let's look at another one here. Now notice we have a negative number we are plugging in. Do not forget parentheses when you plug this into your calculator. We also know when we square a negative, we will always get a positive, because to be squared means multiplied by itself. Negative times a negative is always a positive. So again, just to kind of recap what I like to do, I like to just go ahead and leave a space where I'm plugging in my x value. And again, we're asking, does this equal 55? Well, what is x? X is negative 5. So where I left those parentheses, I'm going to go back and fill in. And now it's a matter of order of operations. So, exponents. Negative 5 times negative 5 is 25. 4 times negative 5 is negative 20. And does that equal 55 as we continue to simplify? 3 times 25 is 75. Minus 20. Does that equal 55? So notice I'm sort of simplifying the left side. I just keep the right side. I am checking this as we go. My very last step, I'm going to simplify 75 minus 20. That equals 55. So my question that I asked in the beginning, when x is negative 5, does the left side equal 55? Because we said 3 times something squared plus 4 times something must equal 55. So what value of x makes the equation true? So did x equals negative 5? Was it a solution? Did it make the equation true? Does left side equal right side? Yes. So therefore, x equals negative 5 because it made the equation true. Left side equaled right side. So now you are going to go ahead and do C on your own. So again, be careful with plugging in, especially here. Now the one little reminder I'll give you is that don't forget this negative Don't forget your coefficient there would be a -1, so it's -1 times x cubed. So watch out with your order of operations there. Okay. So that's essentially the same thing as a table, what we were just doing, where we were substituting or plugging in values. We were saying, hey, let x equal this, and let's see what our outcome is. So now let's look at a graph. How does a graph represent the solution to an equation? So we have an x-axis and a y-axis, and we have points all along this x-axis, y-axis, this coordinate plane, or this first quadrant. So we can read the graph. So when x is 0, the height is 18. So when x is 0, y is 18. When x is 1, when x is 1, what is y? It looks like it's pretty close to 15. Now this is just an approximation because I don't know for sure, but it looks pretty close to 15. So I go to where x is 1 and I find where's y when x is 1? It looks to be 15. So now, what about when x is 2? Let's go and see where the graph is when x is 2. When x is 2, y appears to be 12. When x is 3, we look up, go and find your graph. When x is 3, it looks like y is about 9. And when x is 4, it looks like y is 6. That's how we can use a graph to find the solution to an equation. We say, okay, when x is this, where is that graph? Where is that point in the coordinate plane? When x is 1, y is 15. That's where my graph is when x is 1. One other thing I want you to do for tomorrow, look at these values again and tell me, does this look like a constant increase or a constant decrease, and be able to tell me why. So you're going to jot that down. But again, when it comes to finding solutions using a graph, you go and find x, given the x value, and then find y. Where is y on that graph? So in this case, our graph was a line. So when x is 1, we went and found y. When x is 5, we can go and find y. It looks like it's probably going to be about 3. So knowing that, go ahead and answer the next question there. What is the height after 6 hours, or at 6 hours, and how do you know? Okay. Last thing we're going to be talking about is defining a variable. So what does that variable represent? And then setting up an equation and then solving that equation. And today we'll be using tables again to solve that equation. So using tables, again, more kind of trial and error. Take the values of x and plug them in until you get the right answer. So the Smiths are saving to send their child to college. They currently have $5,275 in the bank and are saving $950 per year. How many years will pass before they save $20,000? Okay, so they currently have $5,275 in the bank and are saving $950 per year. How many years will it be before they save $20,000? So let's kind of go back and pick this apart. They currently have $5,275. That's flat, that's no matter what. $20,000 is how much we want at the end, so that's representing a total. What is changing? Each year you're adding how much? $950. So would this be a constant increase or a constant decrease? It's a constant increase because we're adding $950 each year. So we want to define a variable. It says how many years. So what are we looking for? We are looking for the number of years. You can make that whatever variable you want. You can make x, y, t, q, whatever you want. I'm just going to stick with x for right now. So when we define a variable, we actually want to say what that variable represents. So we can say let x equal the number of years. So that's what it means when we say define the variable. What does that variable represent? So when we come up with an answer, we know what we just found. So let's go back. We want the totals 20,000. So we can say, okay, we want something to equal 20,000, the total amount. We already have this $5,275. We are going to add that amount we already have, to the $950 per year. So how do I represent that? How do I represent $950 being added every single year at a constant rate? $950 for every single year. So this is my equation. Again, x represents the number of years, so $950 per year. So how can we solve this? We can make a little XY table. So this is years, and this is total. And we're just going to say, okay, what do we want to plug in for x? What do we want to start with? I don't know, let's start with, and this is kind of up to you, let's start with 10. Let's see what happens when x is 10. What does the total come out to be? Remember, what do we want the final amount to be? 20,000. 5,275 plus 950 times something, we want it to equal 20,000. So let's pick up our calculators and just try it. 950 times 10 plus 5,275, 14,775. Okay, so I'm still off a little bit. So you could try 15, you could try 20. I'm going to go ahead and jump up to 20. What happens when x is 20? We get 24,275. So that's too much. So we got to go back down. So this kind of gives me an idea of where I want to try. What numbers do I want to try to plug in? So let's try 15. 950 times 15 plus 5,275, and we get 19. We're pretty close there. So 19,525. So because we're very close, the outcome's very close to this 20,000, let's see what happens when we plug in 16, because we need just a little bit more. Okay, when x is 16, we get 20,475. So what does that mean? That means we'll have $20,000 in the bank somewhere between years 15 and 16. So, about how many years between 15 and 16 years is when we'll have that $20,000. So again, you just pick a number you want to plug in for x, see where it gets you, and that tells you, do I need to go higher or do I need to go lower? And then as we start to kind of zero in on that amount, we can fine tune it and just try 1, or maybe we could even try 15.5 if you want to start to get really exact. 15.25. So that's just how we do that. Define the variable. What does the variable represent? Set up your equation. Again, was it a constant increase or constant decrease? And then we start plugging in values to a table using our equation that we created. Okay, next one. Avery is saving for a used car that costs $12,000. He has $3,350 in his savings account and saves $325 per week. How many weeks will it be before Avery can buy his car? So I'll kind of start this one off for you. Again, let's pick out our key information. Saving for a used car that cost $12,000. So what is that representing? That's the total amount. He has $3,350, so that's a set amount no matter what. Saves $325 per week, so every week he's saving another $325. How many weeks will it be before Avery can buy his car? That question usually tells us what our variable is going to be. We are looking for how many weeks. Because that is the unknown, we don't know, that's my variable. So we can say, let W equal the number of weeks. So now, we know the total is 12,000, so math total is equals. Is it a constant increase or decrease? Increase, we're growing every single time because we're adding that much to the account. So how can I represent that? 325W. And what am I adding that to? I'm adding that to the 3350 that I've already got in there. So now, it's going to be your job for homework tomorrow to go ahead and make your XY table. Got a little carried away there. Or we know it's W for weeks and T for total, if you want to think of it that way as well. And start plugging in values and say, okay, what's going to give me the 12,000 or something very close? So that's what you have to do for tomorrow, and I will see you and we'll work on more problems then.